I'm at Tycam Engineering in St Neots. 4 years ago, none of these machining centres were here. I'm going to speak to Andy, who's the managing director of the company. He's going to tell us why he's invested in this technology from XYZ. Andy, so you've got 4 machining centres here. 4 years ago, they weren't here, and you had sort of CNC bed mills or milling machines from XYZ. Why the change to the machining centre?
Customers develop their jobs. Instead of it being fabricated from lots of different parts, it's basically one part with all the different components machined into it. The only way forward was machining centres.
And it's a big investment for you. You're a small business, a successful business, and a lot of the work that you were doing was one-offs, two-offs, fives, tool room work. Is a machining centre the right machine for that?
Yeah, I mean, you do hope that all your one-offs and your two-offs are going to turn into 50-offs and 100s-offs. It just covers all bases. And
that's exactly where the LPM comes in, Nick, because you're a big fan of the PMX control. Tell me about your experience with that.
Well, the very first CNC that I ever used was a retrofitted Bridgeport machine, which had the original EMX2 control from XYZ. So I've just followed it through right from when it very first started now to as far as we've got now.
So with the previous CNC bed mills and the control you had on those, what's the transition, what's the learning curve when you step up to the LPM with the ProtoTrack PMX?
It's exactly the same. There's no learning curve. It is exactly the same.
So I'm kind of establishing this opinion then that this machine takes your business, gives you the ability to do the tool room type work that you used to do with your bed mills, but also gives you the option of going into production too.
Absolutely. That's why I've got them. Absolutely.
Right, let's have a look at how easy this is to program. So we'll do a simple part. Chris will come in with a camera and we'll have a look at you programming your way through a component.
Okay, so very straightforward program. You'd go to the beginning. Here we've got with a mill across the top. You'd go to mill. So we'd start just back past the job, say -30. Centre of the job, which on this job would be 12 mil up. Rapid down to 1 mil above the job, end on 0. Go past the job, perhaps, I don't know, 60 mil. Keep it in the centre, keep it on the height, no corner radius. Cut it down the centre, RPM 5,000, 300, tool number 1.
So what you haven't done is put the size of the part, you've just done what you want the machine to do?
Yes, absolutely.
Yeah. Okay, so what's next?
So we'd profile around the outside. So if we stop down the bottom corner there on 0, rectangle, 0 and 0, which is down the bottom, and then we'd go -18, and we'd go +24. Wrap it down to 1 again, minus enough to cover the job, so -15. The corner radius, 4. Direction clockwise, tool offset to the left, where it asks you, gives you your options. Go around perhaps twice. A finishing cut, clean it up nice, 0.2. 6,000 RPM, 6,000 to finish, 100 feed, 300 on the X and Y, 300 to finish it, and that would be a different tool, so we say tool number 2.
It's guiding you all the way through, isn't it?
Yeah. It asks you what to do rather than you telling it.
So now what are we going to do next?
Okay, so now we can put these circular profiles in. A profile, there's your options again. Circle profile, -4, +4. Z wrap it down to 1, above the job, and then I want to go -4. And the radius on those are 4 mil. Direction 1. Offset 2 again, 3 passes, clean it up, copy from the last profile.
So we're pretty much there already.
Yeah, simple, just do the next, you just do the next frame on the other side, and then to add some holes. So go to end of the program, drill, I mean there's lots of options. -4, +4, 1 above, -5, yeah, 3, and there's a hole in the middle.
I think that's enough, Andy. I think that demonstrates within that few minutes how easy it is to take a drawing. Yeah. So it means your customer, a customer can come in here with a component or with a drawing and say, Andy, turn this around for us quickly.
That's what they do.
Even though you've got a machining centre, you can do that.
Yeah, absolutely. You can stop what you're doing, quickly do that, and go straight back to what you were doing.
But you've now taken the business into a different dimension with the element of production, because some of your component runs have gone up to 50s, 80s, 100s. Yeah. These machines are fast machines as well, so they achieve the precision machining results you want to.
Absolutely. Yeah, absolutely. And it's so easy having been brought up, if you like, and then coming through engineering with ProtoTrack. If you need to make the slightest little change, or you know where there's something's not quite right, you can go straight into it, find it, cure it.
Just tell me a little bit more about this system here. You've got A, B and C. What does that do? Okay,
so these are Jurgens. Basically, it gives you 3 different positions to put your job. So if you can have a larger plate, or you can have a smaller plate, or the medium size. Basically, they just give you a fixed position. So when you program your job, you put in what position you were in, and next time you want that job again, you just pick it up, put it back in.
So it's like it's a clamping system that enables you to take this, again, gives you that ability to go from one job to another very, very quickly. Yeah. And this is integral to the machine.
Yes. Yeah, I could take this off now, put another plate up, do a job, put this back, and say it was in position B, and that will know exactly where that vice was.
Now tell me about some of your other work holding. What else do you use?
Vacuum tables. Again, I have a vacuum table that's mounted onto a base plate, which so you can just undo the vice. It saves all the clocking up. Screw back down the vacuum table, do whatever I need to do, take it out, put this back.
And it's not just the LPM, we've also got the what is very popular, the 2-op machine from XYZ. You got 4 machining centres, you went for that then as a 5th. What's the 2-op doing in here? What's that going to do for you?
2-op serves 2 purposes. It's brilliant just for running small parts, keeps your bigger machines free, but also for second ops, you can just put it on your pallet truck, wheel it over. First op in the big machine, second op in the little machine, and while that's doing, your next one's back in your...
Essentially saves your legs from taking apart from that machine over to the other side of the machine shop. Yeah. And so when you look at your outfit, very presentable machine shop. I've got to compliment you on the way it looks. As a business, how are things since this big investment, which you've said to me has been a lot more than the mortgage on your house, which was what worried you initially. Yeah. But has it paid off for you?
I get a bit more time at home, and that's true. The 10 o'clock at nights aren't so important anymore.
But why is that? Is that because you can leave the machines running, or you're doing stuff faster in the day?
Yeah, you're doing stuff. You're getting a lot more stuff done faster. You don't have to wait for something to finish before you can do something and then get back on it again.
And if you had to kind of quantify, or if you had to summarise what the XYZ machining centres have now done for Tycam, what they've done for you as an individual as well, what would you say?
Changed everything. ProtoTrack originally changed everything, and then the LPM changed everything again.
Double whammy.
Double whammy.
So this is an example, Andy, of what you're making here at Tycam, all of this being machined on your XYZs.
Yes. Yeah.
Let's start with this first part. Tell us the process and how quickly it takes.
Okay, so the customers very kindly kept it down to 2 ops. So we'd skim the top, machine around the outside, machine up the middle, drill it, tap it, and it's under 20 minutes.
Pretty quick, pretty quick.
Very quick.
All right, part number 2. Let's have a look at this one.
Okay, so this is, has its first op done on one machine, just in the vise, skim it, drill it, countersink it, then I lay it flat in an air table and machine all the middle out with just the one cutter, so it's around about 40 minutes, but it's finished.
And the vacuum work holding is what you need to pull that down, I assume?
Yeah, I wouldn't be able to work without it. Yeah.
Then this part, this would be...
Yeah, so this is a few more ops. Everything's done on the bottom surface first, and then place it over, do the top surface, do all around all 4 sides. Well, I should think to machine out in the middle and tap it, it's around about 40 minutes.
So pretty quick, and this is a final one. I want to look at this.
Yeah, this is a very typical situation when you get asked to make 2 of these in, you've got 2 days.
And how do you go about that? Do you program that on the controller, or do you do that offline?
Well, after you said yes, I will do it, as you have to. Yeah, it's all programmed. It comes in as a DXF. Take the DXF out of, post-process it through SolidWorks, put it into XYZ's offline software, write up the program, When the program enters the machine, all your two-dimensional positions, shapes, holes, everything's in. You just add your depths.
So 2 ways of feeding this machine.
Yes.
Program at the control, simply and
Yes.
easily as we've seen.
Yeah.
And secondly, using DSX files or DXS files and importing them via a post, and the program is then created and ready to go.
Absolutely. Yeah.